On March 2, 2026, at 2:43 a.m. Eastern Time, an unexpected alert reached the White House Situation Room. It came not from a report of an incoming asteroid or an impending collision, but from NASA's Planetary Defense Coordination Office. The focus of the alert was on a comet, one that most people believed had vanished 5 years ago, Comet C 2019Y4, also known as Atlas. Initially, this comet had been written off as a routine casualty of space, its dramatic breakup in early 2020 sealing its fate. By the time it faded from view, Atlas was believed to have simply vanished. But the alert was about to change everything. As soon as the notification reached the highest echelons of the U.S. government, the atmosphere in Washington shifted dramatically. Within hours, senior officials from the National Security Council, the Department of Defense, and the intelligence community had gathered for a secretive emergency session. By midday, members of Congress were receiving classified briefings, all revolving around a re-examination of historical data about Atlas. While the public statement sounded harmless, behind closed doors, the real reason for the urgency was clear. Something in the old data had been reinterpreted, something serious enough to elevate an obscure comet into a national security issue. The question swirled around why Atlas, after being dismissed for years, suddenly demanded such immediate attention. What had changed in the data to make officials in Washington scramble? To find out, we need to journey back to 2020. As the world was grappling with the pandemic and chaos was spreading across the globe, astronomers had been tracking the trajectory of Atlas, which was rapidly brightening as it approached the inner solar system. Yet, just as interest peaked, the comet began to fragment not gradually, but violently. It broke into dozens of pieces in an explosive manner, a spectacle that would normally have triggered a flurry of scientific collaboration. But in the midst of a global crisis, the response to this unusual event was muted. With scientific conferences canceled and research facilities operating with minimal staff, no real-time analysis or critical investigation into the fragmentation occurred. While the Hubble Space Telescope captured images before the breakup and ground-based observatories tracked the fragments, there was no coordinated effort to delve deeper into the anomaly. The world was too consumed by the pandemic to worry about what was happening in space. By summer 2020, Atlas had disappeared. Its fragments vaporized as they approached the sun, and the comet faded from both sight and memory. The data collected was archived, its findings set aside for a future that never seemed to arrive. But in late 2024, something crucial changed. Dr. Patricia Hammond, an orbital mechanics specialist at the Johns Hopkins Applied Physics Laboratory, was tasked with updating risk models for interstellar object encounters. As part of this routine work, she revisited Atlas and noticed something that stopped her in her tracks. In early January 2025, she realized that the comet's trajectory was behaving in a way that didn't align with what should have been expected. There were subtle changes in its path changes that were too precise to be explained by the normal forces exerted by the Sunday comets, when they experience outgassing, tend to exhibit irregular movement. But Atlas was behaving differently. Its orbit appeared to be gently corrected and maintained in ways that defied the natural laws of physics. By January 9th, Dr. Hammond escalated her findings, and within days, independent teams confirmed her suspicions. This was not just another comet, this was something else entirely. The question was not what Atlas was, but who or what was responsible for the way it was behaving. Once the findings reached Washington, the situation escalated quickly. What had initially been viewed as a curious anomaly soon became a matter of national security. Dr. Hammond's findings weren't dismissed as just another technical curiosity. When her supervisor passed along the analysis to the Planetary Defense Coordination Office, the response was immediate. Within days, 3 independent review teams were tasked with reprocessing Atlas's trajectory. Each team worked independently, unaware of the other's actions. Yet, when all 3 teams completed their analysis, they arrived at the same conclusion. Atlas had made subtle course corrections. These weren't dramatic shifts, the kind that would normally trigger an automatic alert, but they were enough to raise serious questions. Atlas was not just drifting passively under the influence of solar forces, it was actively maintaining its trajectory, as though someone or something was controlling it. On January 16th, a researcher cross-referenced these trajectory anomalies with high-resolution images of the comet taken before it fragmented. What he found next was even more startling. The surface features of Atlas didn't match what was expected of a typical comet. Instead of being covered with irregular pits and jets of gas, Atlas showed smooth, flat regions, straight edges, and rectangular shadows, features that didn't align with natural fracture models. At first, these patterns didn't seem like much, but when combined with the unusual trajectory, it became clear that something was wrong. These weren't just random imperfections in the comet's surface. They were deliberate, or at least appeared to be. By the morning of January 17th, the analysis had crossed a threshold. A formal briefing request was sent to the White House. The document wasn't filled with speculative theories. It was a risk reassessment. The question was no longer whether Atlas was an anomaly. The question had become, what if Atlas wasn't natural at all? The implications of this question were massive, and it wasn't just about a comet behaving unusually. It was about whether the United States had missed something far more serious. This was a threat that hadn't been recognized because of its subtlety, and now, after 5 years of silence, it was being acknowledged that Atlas might not have been a natural celestial body at all. It could have been something deliberately engineered. This realization was enough to send shockwaves through the government. Officials from various sectors began to piece together how this had happened. In 2020, when Atlas was passing through, global coordination was severely disrupted. The pandemic had thrown everything into disarray. NASA's operations were scaled back, and planetary defense systems were stretched thin. If someone had designed Atlas to approach Earth during this precise moment of chaos, it would have been the perfect opportunity to test humanity's response capabilities. In the early months of 2020, planetary defense wasn't operating at full capacity. International cooperation was minimal, and tracking resources were depleted. Atlas had passed through Earth's proximity during this ideal window when attention was fractured and global systems were under severe stress. This only heightened the feeling that something more insidious had been happening in 2020 than anyone had realized. The briefing requested by the White House began to outline these concerns, and the tone of the discussions quickly turned from curiosity to alarm. The key takeaways from the classified sessions were clear. First, Atlas demonstrated controlled orbital behavior inconsistent with passive celestial mechanics. Second, its surface morphology deviated from known cometary structures in ways that could not be explained by natural forces. And third, its closest approach happened during a period when humanity was least prepared to assess such an object. In short, Atlas had been allowed to slip through Earth's defenses unnoticed, and no one had realized it at the time. That discovery alone turned the event from an academic curiosity into a significant national security concern. As the analysis continued to unfold, the sense of urgency within Washington grew stronger. Dr. W.Y. Richard Saunders, a former Deputy Assistant Secretary of Defense with years of experience in threat assessment, was brought into the loop on January 19, 2025. When I spoke with him soon after, he chose his words carefully, but the concern was clear. What troubled him most wasn't just the data showing that Atlas had behaved strangely, it was what the data didn't show. The fact that nobody had been looking closely enough in 2020 to raise the alarm was what truly bothered him. There had been no protocols in place for recognizing intent, no frameworks for escalation. If Atlas had been deliberately designed to pass through Earth's defenses, it had been able to do so with little resistance. The systems that should have caught it were overwhelmed or underdeveloped, and there had been no coordinated response to its unusual behavior. As more officials were briefed, the conversation shifted from speculation about the comet's nature to deeper, more uncomfortable questions. For the first time, Atlas wasn't just a puzzling object in the sky, it was being considered as a potential test. Could it have been sent here deliberately to see if the systems in place to detect such objects were up to the task? This was no longer about a single anomaly in space. It was about a fundamental flaw in humanity's ability to monitor and respond to potential threats from beyond the solar system. The realization that Atlas had gone unnoticed was the catalyst for a much broader reassessment of planetary defense. On January 20th, Congressman Jake Morrison, chair of the House Subcommittee on Space and Aeronautics, was briefed on the findings. 2 days later, he made a public statement calling for immediate investment in planetary defense, regardless of whether the object was natural or artificial. But this wasn't just a call for more research, it was a signal that something serious had been uncovered. Behind closed doors, the conversation was even more direct. Representative Sarah Chen, a ranking member of the same subcommittee, confirmed that NASA had briefed lawmakers on an object displaying behavior inconsistent with known cometary physics. While no one would use the term artificial, by this point, the concept was already widely accepted. Atlas wasn't just an oddity, it might have been an intentional test. As the potential scope of the issue began to sink in, the tone of the discussions shifted from curiosity to damage control. By January 23rd, NASA had issued a quiet, low-profile press release announcing the creation of an Interstellar Object Characterization Task Force. It was a small, understated move, buried among routine press releases, but it held immense significance. This was no longer just about scientific inquiry. This task force was being designed to bridge the gap between astronomy and national security. It was a recognition that unexplained behavior in space could no longer be dismissed as scientific curiosity, it was a potential threat. Behind the scenes, NASA and the Planetary Defense Coordination Office were requesting a significant increase in funding, nearly 300% for the next fiscal year. New sensors and space-based technology were being fast-tracked, and international data-sharing agreements were being drafted to prevent another Atlas-like oversight. For the first time, planetary defense wasn't just concerned with asteroids and comets that could collide with Earth. It was about identifying and tracking any object, whether it was a natural rock or something far more deliberate. This shift in focus wasn't just happening within NASA and the U.S. government. Research institutions across the country were receiving unexpected calls from the intelligence community. A colleague at MIT, who worked on adaptive optics for ground-based telescopes, was contacted about compressing a 10-year imaging project into just 3 years. But this wasn't a request funded by the usual science grants. The funding came from a classified defense allocation. The goal was clear: compress decades of research into just a few years in order to develop high-resolution imaging of small objects at extreme distances before they fragment or vanish. The government was preparing for something, and it wasn't just about planetary defense anymore. It was about knowing what was out there and being ready for anything. The intensity surrounding the Atlas anomaly continued to rise, but most of the public remained unaware of the true implications. On January 25th, I received a call that left me unsettled. It came from a former student who now worked inside the intelligence community. We hadn't spoken in years, but his message was simple. I was asking the right questions, particularly about the timing of Atlas and why the systems weren't prepared. He urged me to focus on the critical details, why the detection systems had failed, and how an object like Atlas could slip through the cracks when the world's attention was so fractured. After he ended the call, I couldn't shake the feeling that there was something bigger happening behind the scenes, something that hadn't been fully explained. That question, why the systems weren't ready, reframed the entire Atlas scenario. If you wanted to test the planet's detection and response systems, you wouldn't announce yourself. You'd send something small, something that looks natural at first glance, but behaves in ways that can't be easily explained. You'd want the object's deviation to be subtle enough that it could be dismissed as noise. Timing would be crucial. You'd wait for the perfect moment when global coordination was at its weakest, when international attention was divided and distracted. In early 2020, during the height of the pandemic, the world was distracted. Attention was fractured, resources were strained, and many systems were operating below capacity. Atlas had passed through during this exact moment of vulnerability, and by the time anyone noticed, it was too late to take meaningful action. This idea that Atlas wasn't a random comet, but rather a deliberate test started to gain traction in policy circles. If Atlas had been sent intentionally, it had been an experiment, a test of Earth's defenses, a way to probe our vulnerabilities without ever triggering an alarm. And when you look at the trajectory of Atlas, the way it behaved, the timing of its approach, everything begins to line up disturbingly well with this theory. The fact that it wasn't a direct threat, didn't shine unusually bright, didn't move at extraordinary speeds, and didn't pose a significant risk of collision made it all the more perfect for such a test. In the old system of planetary defense, objects like Atlas didn't score highly on the metrics that mattered, but under the new lens, the picture began to change. It wasn't about size, speed, or collision probability. It was about the behavior of the object, its predictability, its subtlety. As the discussion progressed, it became clear that Atlas wasn't just a reminder of how we had missed something critical. It was a wake-up call that the old system of planetary defense wasn't built to recognize intent, only impact. It wasn't designed to detect subtle anomalies, micro-adjustments, or behaviors that didn't fit within the established norms. It was built to focus on dramatic events, comets that shattered, asteroids that collided. But the real threat might lie in objects that move silently through space, gathering data, observing, and then slipping away without leaving a trace. That realization led to a fundamental shift in how planetary defense systems were being restructured. Analysts weren't just looking for big objects anymore. They were looking for patterns that didn't make sense, for movements that were too precise to be random. These were the new signals that were being treated with urgency. Behind the scenes, classified discussions began to focus on one very unsettling question. If Atlas was a test, what happens next? That question hovered over every decision that followed, every new budget allocation, and every redesign of detection systems. Atlas had shown the vulnerabilities in our monitoring systems, the blind spots that allowed an object to slip by unnoticed. The shift in focus from asteroid impact to behavior patterns wasn't just theoretical anymore. It was a critical reorientation of priorities. By the end of January, the new detection systems were already in development. Space-based sensors were being fast-tracked, and plans for international collaboration were being put in motion. No single country could afford to rely on its own systems anymore. What had happened with Atlas couldn't be allowed to happen again, and if it was a test, the fear was that the next time the object might not be so forgiving. It might not be a comet that fades from view. It might be something far more deliberate, and next time the systems had better be ready. The urgency surrounding Atlas pushed the government to rethink everything it had once taken for granted. In the wake of the comet's passage, officials weren't just updating their systems, they were recalibrating their entire approach to space defense. The focus wasn't just on preventing impacts, it was about identifying and reacting to any object, whether natural or artificial, that exhibited unusual behavior. For decades, planetary defense had been about the big, obvious threats, asteroids, comets, and other objects on collision courses with Earth. But Atlas had introduced a new wrinkle, a silent, calculated movement through space that didn't trigger any alarms. Its behavior was so subtle that it had slipped through the cracks of the existing detection system. Now, the question that dominated discussions was no longer about preventing a collision. It was about understanding why objects behave the way they do and whether there might be a deliberate pattern to those behaviors. Researchers began to shift their focus from size and speed to movement and timing. They started asking questions like, does this object behave like a random piece of space debris, or does it exhibit consistency in its path and speed as if it's being carefully controlled? Is the object's movement chaotic, or is it stable despite the forces acting on it? These are the kinds of questions that had never been asked before, and they were now at the forefront of planetary defense research. The realization that Atlas had slipped through unnoticed during a time of global crisis had massive implications for how governments and agencies would react to future threats. Atlas had exploited the world's most vulnerable moment, taking advantage of the widespread disruptions caused by the pandemic. If this wasn't a one-off incident, if there were other objects out there with similar behaviors, then the consequences of being unprepared could be catastrophic. That's why, in the months that followed, the focus shifted from improving existing technology to creating entirely new systems of detection and monitoring. Space agencies began working together in ways that had never been done before, ensuring that no single country would ever be left to fend for itself in detecting these kinds of threats. But as the pace of progress quickened, the silence from officials became more pronounced. Behind closed doors, discussions were no longer centered on Atlas itself, but on what it had exposed our lack of readiness. The most uncomfortable realization was that if Atlas had been a deliberate test, it had been a test of our defenses, our ability to detect and respond to subtle anomalies. The concern wasn't just about missing Atlas, it was about missing other objects in the future, objects that might be even more subtle and harder to detect. The changes being made were profound. New detection systems were designed to flag even the smallest deviation in an object's behavior. Algorithms were updated to account for the possibility that some objects might not be naturally chaotic, as had always been assumed, but rather controlled with deliberate precision. The goal was clear. Never again would an object like Atlas pass by unnoticed. The new focus wasn't on preventing a collision, but on recognizing subtle, unnatural behavior that could indicate a much larger, more complex threat. As these changes were being implemented, some began to wonder what would come next. If Atlas was a test, as many in Washington now suspected, what had been learned? Was this just the beginning of a new era of space observation, where every strange object would be met with skepticism and scrutiny? The unsettling truth was that Atlas had shifted the conversation from planetary defense to planetary vulnerability. The world had been caught flat-footed once, and no one was willing to let that happen again. But there was another, even more troubling question that officials weren't eager to discuss. If Atlas had been an object designed to test Earth's response capabilities, then what would be the next step in this test? Was it possible that the next object to approach would push humanity's defenses to their breaking point, testing not only the technological systems in place, but also the very concept of global coordination? The shift in priorities from detection to response, from prevention to observation, was a recognition that the next time humanity might not be so lucky. As the weeks passed, the urgency surrounding Atlas began to settle into a new, uncomfortable reality. It wasn't just about fixing the mistakes of the past. It was about fundamentally transforming how humanity understood and responded to space threats. The old systems of planetary defense, which had focused on the physical characteristics of objects, were now being expanded to include behaviors, patterns, and timing. The quiet, calculated movements of Atlas had exposed a flaw that could no longer be ignored. If an object could move subtly, adjust its path with such precision, and escape detection under the most chaotic conditions, then what did that mean for future encounters? The answers to these questions were still being developed, but the shift in approach was undeniable. Planetary defense had to become faster, more proactive. The focus had to be on monitoring every object, no matter how small or seemingly insignificant. Detection systems needed to be recalibrated, thresholds lowered, and the capacity for rapid response needed to be increased. And the most important lesson from Atlas was that no object, whether natural or artificial, could be allowed to slip through the cracks again. The goal was no longer just to avoid impacts. It was to be ready for anything that came through, regardless of how it behaved. Behind the scenes, major developments were taking place. Space agencies around the world were updating their detection systems and improving their international collaboration. Agreements were made to ensure that no single country could miss an object like Atlas due to bureaucratic delays or political distractions. The need for a more unified, coordinated global approach was now clear. The fear that Atlas was not an isolated incident, but a symptom of a much larger problem, had become a driving force in the discussions. As the analysis of Atlas continued, officials started to ask a new set of questions. If Atlas had been a test, then what had it learned? What weaknesses had it exposed in Earth's ability to respond to subtle space anomalies? And perhaps most troubling of all, officials began to wonder if Atlas had been more than just a test of technology. Could it have been an observation, a silent reconnaissance mission, gathering data on how humanity would respond to the unexpected? If Atlas was designed to observe, then it hadn't been about a collision. It had been about watching, learning, and preparing for something far bigger. And if Atlas had been observing, then who or what was behind it? These were questions that few were ready to answer, but all were quietly thinking about. The silence that followed the briefings in Washington was the most unsettling part. No dramatic announcements were made, no new threats were declared. But in many ways, that silence was louder than any official statement could have been. It signaled that the decisions had already been made. The systems were being rebuilt, and Earth was preparing for what might come next. But the most important question had already been answered. If Atlas was a test, then the next object might not be as easy to miss. And it might not be as forgiving. The actions taken in the wake of Atlas's discovery were not based on certainty. They were based on plausibility, paired with the very real consequences of being wrong. As the new systems took shape, the question that remained was whether they would be enough. Would they be fast enough to catch the next object before it slipped by unnoticed? Would they be able to detect a subtle deviation in an object's movement and raise the alarm in time? The fear wasn't that Atlas was an invasion. The fear was that it had been something far more insidious, a test, an observation. And if that was true, then the stakes were higher than anyone had realized. For now, the focus is on readiness. The systems are being built not just to detect, but to react, to respond before it's too late. And as the world's attention shifts toward these new priorities, the question looms larger than ever. If Atlas was the warning, then what comes next? The silence that followed the briefings wasn't just about the absence of answers. It was the quiet before the storm, a moment of reckoning for a world that now knows just how vulnerable it truly is. As the global community accelerates its efforts to enhance planetary defense, one thing is clear. Earth is no longer assuming that everything in space is what it appears. The systems are changing, the mindset is shifting, and humanity is preparing for a future where subtlety and precision may be the new norms for space threats. The age of complacency is over, and the stakes have never been higher.